We'll continue to work on projectile fired parallel to the horizontal. Now the next component is time of flight. Time of flight. So basically time of flight is to do with the total time the object is in air. Okay. So first thing that what will affect the time? Think about it, it's kind of commonsensical point. The height, is it not? Right? If we consider this as h, the height affects it. More the height, more the time of flight. As simple as that. So time of flight depends on what? On the y component. So we know that total height total height is h unit. So now for y is equal to h, what will happen to this expression? Not this though. Let t be equal to t. Okay, time of flight we're taking it as capital T. You guys agree with this? By the time the object reaches to a height of h, let me take this. So by the time the object reaches to this point, it would have traveled a distance of h. From here, it will travel down to a distance of h. So if we happen to travel a height of h, the time that we consider is t. That is the time of flight. That's a very definition. Therefore, y will be equal to half of, we're taking equation 2, g will be g and t will be t square. This is from 2. So we want expression for t. So t is equal to, and sorry, by the way, this is h, by the way, not y. So t is equal to 2h by g. T square is equal to that. And t will be equal to root of that. Okay, I don't want to write that, or let me write it off. Oh, that's so many seconds. That's a general expression. So that is your time of flight. Next, we look at r. The distance the particle has flown, right, from here till here. That's your r. That is known as horizontal range. One more thing that we're looking at is horizontal range. That's your r. So we know that the horizontal range will increase with what? See, if I keep increasing this distance, right? If I keep increasing that, what will happen? Right? For every time, if I keep increasing 5 seconds, 6 seconds, 7 seconds, what is happening? Further away. So more the time, further away it is going. So the highest time that the object will get is how much? Yes, time of flight. So for t is equal to capital T, x will be equal to r. By the time the object has flown all the time of flight, it will reach its maximum distance r. But we know that x, which is equal to ut. Okay, this you guys should be remembering. R will be equal to u is u of x in my case. And time of flight is t, which is equal to, we just derived it, 2h by r. So that is your, 2h by g. So that is your range. So basically, r is proportional to root of h and r is inversely proportional to gravity, root of gravity. That makes sense. If I happen to throw an object on the surface of the moon, the range will increase. Okay, so I do have something for you guys with this. I not yet opened it, but now I Okay, not that. So if I happen to increase my, if I forget about the first part, just think about this. If I happen to increase, yeah, if I happen to throw from here, this would be the range. But if my acceleration due to gravity is less, my path will be a lot more like this. It will go further and further. Why? Reason being the pull is low. I'll get more chance to fly forward. And of course, it is dependent on how much force we are throwing with to begin with. Okay, it's kind of commonsensical. So you can see the range depends on at what height we are throwing at, depends on what is the gravitational pull, and of course it depends on with what amount of force we are throwing at. Indirectly, it is u of x. Right? It's a continuation, so you need to write this. And yes, we need to remember all of this. I don't like to remember, but we don't have an option.